Hey guys, it's Miss Beecher, and this is writing equations of cubic functions. I'm just going to teach this one to you by examples. We're going to do 3 examples. So the first one is write the equation in f of x equals a times x minus h all cubed plus k. And notice that we left the b out on purpose. So they'll show you that we're only going to use a, not b. Write it of the cubic function with an inflection point at 2, 1 and passes through 3, 4. So our inflection point we know is hk. We learned that yesterday. And then it passes through another point, so we're going to use that as our x and y. And now we have all the letters that we need except a, and we've done this before. We're going to plug everything in and find a, and then we can write the equation. So if we plug in a 4 for y, we don't know a 3 for x, a 2 for h cubed, can't forget to cube it, plus k, so plus 1. Then we have 4 equals a times 3 minus 2 is 1, and 1 cubed is 1. 4 equals a plus 1. That means that 3 equals a. So now that we have a, we can write the equation y equals, or f of x equals, I should actually do. But it won't let me erase, so y equals, our a is 3, and then x minus h, so x minus 2 cubed, plus k, so plus 1. And that is that. So here's another example. Write the equation in f of x equals parenthesis b, parenthesis x minus h, close both, cubed plus k. So this time we have the b, and please note that this parenthesis and this parenthesis are necessary because the b is being cubed. It's part of the group that's being cubed. So we're going to write the equation of the cubic function with inflection point 1, negative 1, and passes through negative 3, 2, and 5, 0. So sometimes they're going to give you 2 points, and that's fine. You can use either one. I just went ahead and gave you 2 in here just so you could see that it doesn't matter. You can pick whichever one you like to use for x and y. So this will be our h and our k. And I like 5, 0, so I'm going to use 5 and 0 for my x and y. Now, I didn't do this in the last example, and I could have, but I often find it's helpful, if we just sketch what we've got. So we know our inflection point is at 1, negative 1. It's right here. We also know it passes through negative 3, negative 2 over here, and 5, 0 over here. So we can tell that it's going up this way and down this way. It just helps you to get a visual of what it looks like. But the steps are still the same. We're going to plug a 0 in for y, parenthesis b, parenthesis 5 for x, minus 1, close them both, cubed, plus k, so minus 1. Make sure you put all the parentheses in there the way they go. All right, so now we've got 5 minus 1 is 4. So 0 equals parenthesis 4b, close the parenthesis, cubed, minus 1. Don't cube the 4 yet because we want to solve for b, so we don't want to make b bigger. We want to actually go the other way and add 1 to the other side. So 1 equals 4b all cubed. And then we want to take the cubed root. So the cubed root of 1 equals 4b, and the cubed root of 1 is 1, and I'm going to divide both sides by 4. So now I know that b is 1/4. So we're not cubing what's in there because that would make a mess out of things. We want to actually uncube by taking a cube root. So we can write our equation y equals, and then we've got parenthesis b, parenthesis 1/4, parenthesis x minus h, so x minus 1, close them both, cubed, plus k, so minus 1. Make sure you put it in that format. Practice this if you're not used to it. All right, one more example. Write the cubic function in factored form. And factored form looks like f of x equals, we're going to have some a, and then we've got 3 factors because it's cubic, x minus x1, x minus x2, and x minus x3, where x1, x2, and x3 are our zeros of the function. Just like when we did quadratics, only those we had 2 factors, now we've got 3 factors. And here's the picture that goes with the question. Now, my hand-drawn graph is kind of messy, so I went ahead and wrote in the coordinates that you would probably be able to see on the grid if this was a, printed out nice question. So we've got this cubic, and it crosses at 3, 0, and then it touches at -2, 0, and it has a bounce. And we have the y-intercept of 0, -3. So what we're going to end up doing is plugging each of our zeros in for the x1, x2, x3, and we're going to use the y-intercept to find the a value. We'll use this point as an x and a y. So if you look, we only actually have 2 zeros, and that's because this one is a bounce, and bounces mean that we have an even power. And for our cubics, that means it can't be 4 times, so it has to count twice. So if you see a bounce, you know that 0 counts twice. So we'll go with x1 and x2 being -2, and x3 being 3. All right, so we're just going to fill it all in. Our y is -3. Equals a, we don't know yet. And then we have x minus -2 would be +2. And then again, x plus 2, because it counts twice. And then x minus 3 for our 0 of +3. And for all the x's, we're going to put zeros. I could have done that as I was writing it, sorry. Zeros for our x's. So now what we have is -3 equals a times 2 times 2 times -3. So -3 equals a times 2 times 2 is 4 times -3 is -12. Please make sure your times is written in there nice and clear. I've seen way too many times you guys decide to make that a -12 and then add it to the other side. It's times -12. So now we're going to divide both sides by -12. And -3 over 12 is 1/4, which is our a. And so then we can write the equation back in factored form. Y equals 1/4, x plus 2, and it's in there twice, so you can actually write it squared, and then x minus 3. Ta-da! And I know you're glad this video is over, so y'all have a good night, and I'll see you tomorrow.